So let's introduce this idea of measuring perception. If we're going to study perception and create a science from it, then we really need some kind of way to quantify it, to measure it, and to understand it, and to compare results. There are a number of ways to measure perception. We'll look at a specific bunch of them in this series, but I'll mention a couple of others. I think I like to perhaps begin with what we could call the phenomenological methods. Phenomenological methods. Too early for me to be spelling these kinds of words. The phenomenological methods are a class of methods which I suppose are the easiest, and they're something you could probably quite easily do at home. These really begin with something. Let's start with description. One of the easiest ways to measure perception, description. I'm missing my R's. Told you it was early. Description. So this literally relies on our ability to introspect, to look inside and to observe the contents of our own perceptive awareness. So description is one way to measure perception. We could present somebody with something and ask them to describe their perception of it. Many marketers do this. We take consumer surveys in order to measure the perception of a particular product, and so on. So description is one way that we can gain insight into a person's perception. With description, there are some problems though. It's not that easy. There are many unconscious processes that we don't have conscious access to, which can govern our perception. There are I think there's something called, it's called Anton Bablinski syndrome. You may have to. I'll put the link into Wikipedia. I'll find it in a moment. Anton's syndrome, and this is a kind of disorder, kind of like prosopagnosia or Capgras syndrome that we talked about before. But in this syndrome, a person is blind. We can show that they're blind, but they believe that they still have conscious phenomenological vision. They still believe that they have a visual phenomenological field. This is not to be confused with a kind of emotional denial of their own blindness. This is literally they believe that they are experiencing visual awareness even though they are not. So in this case, their description of their visual field is going to be in air. Essentially, it's going to be wrong, and would be unreliable. We won't be able to count on it. Description also allows us to gain insight into an individual's perception, specifically where they are guiding their attention, and this kind of thing, because we will see in later videos that attention is a key part of perception. We may have these neural correlates that seem to produce visual awareness, but without attention, it's very the connection between visual consciousness and attention is hotly debated and extremely interesting. So we'll get to that later on. We could also add into the phenomenological methods. We could say, let's say we've got recognition. I'm kind of creating these categories a bit ad hoc at the minute. Recognition is really, again, it's a phenomenological method. It relies on a person's description or on their own introspective account of their awareness. If we can use this kind of test to perhaps diagnose something like prosopagnosia, where a person cannot recognize faces. If we show them pictures of faces and they fail to recognize them, then this is a way that a recognition task has elucidated something about their perception, has allowed us to gain some insight into that person's perception. There is a number of other recognition tasks that are very interesting. For example, I did a Google image search for a chair earlier, and we can see that we can recognize all of these as chairs. Look at, the difference in shape and form between many of these chairs. These are, there are obviously many different aesthetic and artistic renderings of different chairs here, but it doesn't take much for us to immediately pick out this object as a chair. We know that this is a chair, that this is a chair, even though they're very different in shape and form. See, the variety is very large, and it's interesting then that we can, and so many tests even are performed in this way to see what are the boundaries of how different does something have to be from in order for us no longer to recognize it as a chair. Another form of recognition is kind of to do with the fact that we can recognize objects often from very strange vantage points. So if we looked perhaps top down on a chair, I don't know if I'm going to find a top down image, but we would still, in most cases, we can still recognize objects from vantage points that we've never seen them from before. We only look at, say, a chair. We could look at this chair once from this angle, but we could then recognize it from other angles, even though we'd never seen it from those angles. Furthermore, with recognition, we could obscure much of this object. If you could hold your hand or a piece of card over the majority of this chair and then ask somebody if they recognize what the object was, still, it's interesting to try to figure out how much of the object actually needs to be in view before we can no longer recognize it. So that's kind of an outline of recognition. So we'll see many examples of recognition tests. When it comes to perception, we can see the use of recognition, not only for looking for the limits of perception, but also, like we said, in diagnosing things such as prosopagnosia or visual form agnosia, and so on. Let's have a look. Let's move to a different class of method now, to a set of methods which I suppose came. We're almost working historically here. Phenomenological methods are just very easy. We could do these at home, and then came a kind of class before. It was still prior to much of our technology. It was a class called I'm getting my spelling wrong already. The psychophysical methods. Psychophysical methods. So this is kind of an ingenious extension of the phenomenological methods, where people are saying, okay, so we're getting people to describe things and recognize things, and that's all very good, but how can we begin to quantify, to put numbers on perception? And that's where the psychophysical methods came in. And I mean, we'll do a bunch of videos on psychophysics after this one, just to delve into it, because the methods are so clever. The first one I think we could use, let's use the word detection. Detection is a psychophysical method. So detection really comes about when we ask, okay, so we could recognize, say, a light being shone in our eyes. We can detect, but what is the minimum amount of light that we could detect? If we shone one photon into the eyes of our research subjects, would they have visual conscious awareness of that? Is that enough? Just that one photon stimulating a neuron in the eye, and then that neuron stimulates another neuron. Is that enough to stimulate the consciousness producing, the qualia producing center of the brain? How many photons do we need? This is an idea called threshold. So we have detection thresholds. What is the minimum amount of some stimuli required for our brains to produce it in conscious awareness? So detection really encompasses that. We could also have difference detection. Can we detect the difference between 100 gram weight and 101 gram weight? So difference detection has also played a role. Also, on top of detection, let's say we've got magnitude. Let's call it magnitude. Magnitude. And magnitude detection or magnitude estimation is another of the psychophysical methods, which deals with the question of how to say, if I'm looking at my computer monitor now, it appears in my perception at a certain brightness. Let's say that it's 100 bright, whatever that unit would mean. and we know that the monitor is projecting a number of photons, a specific number of photons out. Let's say it's 1,000 photons. If I double the number of photons to 2,000, do I perceive a doubling in brightness in my perception? What about when I'm looking at the glare of sunlight off of a window, off of a house across the road, and this is very, very bright? There are obviously insane amounts of photons contained in that light, the power of the sunlight and all. But I still don't perceive it as that many times more powerful. And this is what we've discovered from magnitude perception is if we double the number of photons, we do not experience a doubling in the perceived brightness of that thing. And this is different for different senses. So if we were talking about an electric shock, for example, if you doubled the intensity of an electric shock, you would perceive more than a doubling in the intensity of the pain. So for electric shocks, we tend to expand the magnitude of the perception, whereas if it's light, the number of photons, we compress our perception so that we perceive it as less than its actual brightness. Whereas there are others where we do not change the magnitude at all. For example, line length, the length of lines, we tend to be able to perceive that one line is double the length of the other. But this is magnitude detection, so it gives us a way to quantify our ideas about the way that we perceive changes in different stimuli. So magnitude perception is very useful. That's the kind of psychophysical methods at an outline. I'll move on now to the physiological methods. Physiological methods. So how to explain this? One way I like to think about the physiological and the psychophysical methods is to compare them by what it is that they measure. For example, if we said that we've got perception as one dot on our picture here, so this is perception, or the final percept, and then another dot, another marker here is the stimuli out there in the world. Stimuli. Now, the psychophysical methods really measure the relationship between these two. We change the stimuli and we try to discover if there is a change in the perception. So we change the amount of light or the volume of the sound, and we see what happens to the person's perception. But there's a whole load of underlying machinery of neurons. So a third point here, which is neural machinery, neurons, whatever we want to say, and this constitutes the arena that we're beginning to learn about using the physiological methods. So we could, with the physiological methods, we could begin measuring from neurons, and then we could change the stimuli and see if there's a new pattern of activity in the neurons. Or we could be measuring from neurons, and then we could hear a subject, or a research subject could say, something's changed in my perception, and at that moment we try to find a corresponding pattern of activity in the neural pathways. So physiological methods include things like neuroimaging such as fMRI scans or PET scans or CAT scans, or X-rays. These kinds of methods that we can use to get some idea, to create some image of what's going on in the brain, perhaps even electroencephalograms, these kinds of things. Also, perhaps we could include things like lesion studies, which were actually being carried out for a couple of hundred years now. Lesion studies where we say we had damage to the brain, and from that damage, if we can figure out where the damage is done, then we could perhaps try to deduce something about the function of that region of the brain. In the past, we perhaps say that we had to wait until the subject died in order to study the brain and figure out where the damage was, whereas nowadays we can use sometimes neuroimaging to find out the regions that have been damaged. Another one which we will come across a lot, because this is very important in the study of perception, particularly in the visual pathways, is single unit recording, which is where we can now record from a single neuron, and we can measure the activity of that single neuron, or even just a few neurons, and then we can begin to detect what stimuli in the world that those neurons respond to specifically. We'll see that that's important because neuroimaging doesn't really detect from neurons, rather it detects blood flow in the brain, which is a kind of one step removed from the activity of neurons. So these are kind of the methods that I think we'll look at. I'll introduce more if we need to as we go along. But on top of this, let's just add that there are a number of other methods of measuring perception. Psychology is kind of full of methods of measuring perception, although not often with the neuroscientific goal of understanding the brain, but rather of understanding behavior. So perception, there are a lot of methods that have come out of psychology. There's also things such as, we'll write down psychology, things that have come out of like the social sciences and the behavioural sciences, and also things like computer modelling. People have begun to kind of create crude computer models. Well, they're quite advanced, but still nowhere near as advanced as we would like them to be. Computer models of the brain, of the connectomes of the brain, computer models that can help us to understand perception and the way information is processed by neurons in the brain. Again, perhaps when we get something like quantum computing, we'll be able to create the kinds of computer models that we really, really want to create. So that we're looking forward to all of that. I'll leave it there for now. We'll look in the next sets of videos at the psychophysical and a few physiological methods.